Hello and welcome. Give me a second here. I am getting my camera adjusted. Alright. It's been a little while. Yeah. Haven't had time and haven't been feeling good enough to do a stream, but today I'm feeling good. Got my fresh cup of coffee, the good stuff today. So we're gonna get into it. My desk is still a mess. I have not fixed that, but we'll get there eventually. Not today. Maybe this weekend. Alright, let's see here. Camera's all out of whack. Today we're going to be doing an RW-12D. And I don't know if I've done one of these yet. I mean, I've done one of these, but I don't know if I've made a video of one of these yet. But a customer says it's blowing fuses. So I'm just doing the initial look right now. Haven't touched anything on it. I'm just checking it out. And right away the first thing I see is just this brown line of crusty glue right in here. And of course, since I zoomed out, you can't see it. There we go. It's a little better focus. There it is. This is why we're blowing fuses right here. These chunks of glue that are in there. So that's got to come out, and we have to repair the power supply. Since these RW12s are, a little bit older, I'm just going to do a recap on this one too. And a lot of the newer equipment, I've made the decision to not recap the full boards. On the older equipment, I still am going to do a full recap on it. So let's get into it. Let's get this thing taken apart and get it back and working for this guy. This should be a fairly straightforward repair. Uh-oh. Got the fuse jammed in there. That's going to be hard to get out. Well, maybe not. Let's see if this fuse is blown. It probably is. He says it was blowing fuses. Oh yeah, this fuse is toasted. Okay, good. So we'll have to put a new fuse in there. Not a problem. But first we need to get the plate amp off, or the power supply. So it's going to be these 6 screws. Yep, the good old glue. Unfortunately, the RW series is plagued by bad glue. I like these amps though. I have an RW-10D and an RW-10, not the digital version. And both of them have been very good subs over the years. I'm probably going to be selling them soon, not because I don't like them, just because I have too many subs and they're collecting dust right now. So in my area down here, when I eventually get the theater put in, is going to have two Sunfires in it. Not that the Klipsch aren't worthy, but Klipsch really can't compare to 2 Sunfires. That's a tough combo to beat. 2 10-inch MK2s will probably damage my house. Oh, these plugs are really in there. That's good. But they are hard to disconnect. Well, interesting that this one does not have any of the safety locks on it. I don't know when they went to the locking connectors. Alright. Now we just gotta deal with the glue. And this has a lot of glue, unfortunately. We got lucky, it came off with the post, so I can just peel some of it off. You don't need all this glue on there. It doesn't really do any damage down here, but you still don't need it. Alright, power supply is out. It's a cute little supply, but it packs a punch. This is one of my more favorite supplies to work on. So let's, first thing I'm just going to check, I'm going to check the two FETs and see if they're shorted. I'm going to almost guarantee they are, but we'll check them. Usually when the fuse is popping, yeah, they're shorted. Well, at least one of them is. So those got to come out, probably get replaced. The Pdc board needs to come out and get reworked. We got to get all this glue off. Luckily it's on the back, which is good, but usually when it's on the back, that means that the diac on that board is gone and needs to be replaced. I'm checking for some other signs of damage while I'm in here, just looking for some burnt resistors. These units are known for burning up these green colored resistors. And that's just like some current limiting for the lower voltage supplies. Yeah, there's two of them. There's one over here. There's one over here. Sometimes those burn. Yeah, the rest of this amp looks pretty good, actually. The glue needs to come off around these caps here. It has not turned brown yet, which is good. Makes it a little bit easier to get off. The NTC looks good. I don't see any burn marks on that. Of course, it's in a position that makes it really hard to see, so yeah, that looks good. There's no burns on that, so we can leave that alone. We just have to get the PDC going and replace our FETs, and that should get our power supply running again. So let's get into that. Where do we start? We can start by removing the Pdc board, I think. I have not used my long nose tip in a while, so that's the brand new one. I ain't using that one. I gotta find my solder sucker tip. There it is. I haven't used the new one yet. I don't know why, but I don't want to use it yet. This one still has some life in it. I'll give that a minute to heat up, and while that heats up, we'll look for some other issues on here. It's in really nice shape. I'm you know, kind of surprised it went out, but you know, if they would have used silicone on here, and I know silicone, you know, was around back in that time, this never would have died. It's unfortunate. What can you do? Sorry if I'm making a lot of noise with the headset, but I need my coffee to survive tonight. I just clicked on something. I hope I didn't break nothing. Alright, we're almost up to temperature. Bear with me. We're getting there. These boards are pretty well made. Generally, you don't have to worry about ripping through holes out. I don't really necessarily like how they did all the traces on here. I think this stuff could have been done a little better, but that is how they did it. I would have made them a little bit bigger. You have the room, why not make them bigger so they can carry a little bit more power? But they're not burnt or anything, so I mean, it's good enough, just not how I would do it. It doesn't mean my way is the right way either. Alright, I am going to put some leaded solder on here, just to help me out as much as I can. Just dilute some of the nasty lead-free that's on there, make it a little easier to get some of these things off. So we have an alloy now. It is no longer ROHS compliant, which I could care less about. Probably should have stuck with the longer tip, or the wider tip. Sometimes it's hard to get full pins all the way into the solder sucker. It's working for now, but what I need to do is put this on the lathe and drill it out a little bit. Problem with that is you lose the plating, so then it starts to corrode. But it's coming out, so we'll be alright. I would like the hole in the tip of that just to be just a little bit bigger, though. And of course they don't make one. Not an extended reach one like that. I can get a stubby one. Like my stubby one here has a pretty good size hole in the end of it. But it doesn't have the reach. I guess I could shave the nut down a little bit and make it work that way, but it's a lot of extra work. So yeah, here's our problem. The glue has killed this. So we will just scrape as much as we can off with our dental pick, trying not to damage the board. I'm actually going to see my dentist tomorrow. I'm going to ask him if I can have a new set of picks. I'm sure he'll hook me up. They usually go through that stuff pretty quickly. Alright, that wasn't too bad. Hit it with the wire brush, make sure it's clean. Good enough for me. There you go. All the glue is gone. It's all on my mat here. I do clean the glue off the back of the transformer too. Just take a razor blade and just kind of give it a little scrape. You don't have to go crazy. It's like wrapped with this transformer tape. You don't need to rip the tape off. You gain nothing by doing that. Carefully take out our screws holding the heatsink on. You want to be kind of nice and easy with these because it leaves the nuts in place with this glue that's on top there, so it helps when you do that. Alright, we're free, there's no glue. So now we just got to take the solder sucker and get them loose. That one didn't clear. These ones probably should be leaded too. Just something about mixing it with a little bit of the new solder really just makes it flow way better. So that side's loose. Now we gotta go to the top. These should be IRF 740s. Basically the identical design of the sub 12, just everything's laid out a little differently. Like they, over a certain period of years, Klipsch did not change their designs. All their designs are the same. Well, they didn't make the amps either, so. These amps were made by Indigo. And Indigo is the same company that made the 300S that you can get on Parts Express, which is almost identical to what the Synergy sub 10 and sub 12s were. I think the 300S is like a sub 10. Yeah, we have a shorted FET. So we have one shorted FET. The other FET is good. So we will just replace the bad FET. I gotta be cautious with my part replacements too, unfortunately, because the component shortage is real, and getting parts is getting extremely difficult. I only have about 6 of these left. It's an IRF 740. This one's internal rectifier. Let's see if I have an IR. I might. I do, but it has trimmed leads. And that will not work. It doesn't really matter. They don't need to match. And a 740 is a 740. We're going to try and align him up as close as we can to the original spot. And then tighten it back down. And we'll test for fit. Don't want to over tighten. These clamps are good, but if you over tighten them, they lose all of their clamping force. And that is crooked. Me being a perfectionist, I can't have a crooked FET. It's still not perfect, but it's going to drive me nuts. Of course, the nut is too tight to tweak it how I want to. I'm being picky tonight. There we go. That's where it should be. Okay. I'm going to check our gate drive resistors just to make sure that that they're not failed open. Usually they don't, but it doesn't hurt to check them. It takes a second to do. These should be 100 ohms. And they are 100 ohm, 1%. Alright, we're looking good. Everything lines up. And now we can start reassembly. I am going to test this board before we get too crazy. But I want to get this guy back together. And then we can start pulling the caps out. Quiet night tonight. Okay. Let's get those soldered back in. I'm just going to use the solder sucker because my iron's not hot right now. And these large through-hole parts you can use, you know, something like this with a huge tip on it because it doesn't bridge anything together. Earlier tonight I was working on a laptop board and I tried to use this to solder down a chip on there. I needed the heat from it, but it bridged all the pins together. Alright, let's test the Pdc board. And in order to do that, I need this. Just cleaning this up real quick to make sure there's no whiskers on it. I don't want to damage my little socket there. I need a plug. Where's my power plug in this disaster of a workbench? I really am going to clean this bench off and rearrange it this weekend. I have to. It's gotten to the point where it's inefficient. I don't know if you paid attention at the start of the video, but there is a hole in my wall. I'm getting ready to move my fireplace, which is no small task. So I've been kind of busy playing catch up from when I was not feeling well. Okay, I still do not have my power cord. Where is my power cord? I blame the dog. The bad part is I have two of these. And both of them are missing right now. What is this? This is not the cord I need. Jeez, I didn't know it was going to be this much of a pain to find my power cord. What the heck did I do with it? Can't do any testing without a cord. I must have used it for something. Alright, bear with me. There it is. All that for a damn power cord. Alright. Come on, camera, focus. It's mad at me for standing up. Alright, let's see if this Pdc board is good. I'm guessing it's not, but we will find out. There's always the chance. Sometimes you get lucky. Alright, I'm looking for voltage across these two. We're going current limited. Oh, look at that. Pdc board is good. That is a rare treat. When the board has failed that bad with glue, across the whole top and it's still good. That's lucky. We got a discharge. Make sure we don't get any nasty zaps. Pop this out. And I'm going to go ahead and solder it right back in. You got to be careful when you put these back in that you solder them in the right direction. I think actually what saved this is when it was blowing fuses, the owner did not go back and pop like a 15 amp fuse in there and try to power it on. Usually that's the first thing somebody does is they say, okay, well it's blowing a 5 amp fuse, let's put a 10 amp fuse in there. Well, it blows a 10 amp fuse, let's put a 15 in there. And by then everything in the board is just totally smoked. So thank you, owner, for not exceeding the fuse value or the fuse rating. Alright. Now technically at this point this should be fixed. If you wanted to do a cheap repair. I personally would not send an amp out just like that, but some places would. Alright, we are going to power on. And make sure if you're testing too that you put the power in the right spot. I made that mistake once, and I hooked up the line voltage over to here. Yeah, don't do that. That creates a lot of unnecessary work. Everything looks good. Let's see if we have voltage. Oh, you guys can actually see it today. It's better when I do it like that, though. Alright, we are looking for 8 volts. 8 volts means the power supply is working. Not 8 volts means that there's still issues. So let's see what we got. 7.82, close enough. Power supply has been repaired. Now we just got to recap it. Got lucky on this one. Not too bad. Alright, we got to discharge and drain the caps. I got to turn my solder. Well, you know what, we'll do the small caps first. But we are going to drain the big ones. Because I don't feel like getting 200 volts ran through my arms right now. Having a decent repair night. Let's keep it that way. Alright, there are, I think, just 2 on here. I thought there were 3. No, just 2 small caps. And of course they have bent leads on them. They're coming out pretty decent though, not bad. 47 at 50 volts, and I think this is also 47, yeah. So we can take them both out. And these are Junzel capacitors, whatever the heck that is. does not want to clear. Luckily these boards don't have issues with pads tearing off, so I don't have to worry about that. I'm running low on caps too. I checked the other day, and they were out of stock of a lot of the parts that I needed. DigiKey is running on fumes, which is not good for me. Not good for anybody, really. But what I have discovered is that there are brokerages in China that are hoarding parts. So before they even get shipped off to the distributors, these brokerages are buying them all up, and they're charging like 30 times the price for some of this stuff. It's insane. Somebody needs to put a stop to that. I needed some power supply chips, and I can't get them. And they used to be like $2 and something. And the brokerage wants $35 a piece. I can't afford that. These are marked. You just have to make sure the marks are in the right spot. But yeah, it hurts not being able to get parts that I need. I have a lot of projects that are sitting on hold. A lot of work stuff, a lot of personal stuff. A couple of contracted projects or commission projects. I'll be glad when all of this chaos is over, that is for sure. Alright, small caps are complete. Now we gotta deal with the big boys. Alright, here we go. Got two 470s at 200. And we have one 1000. Here's our 470s at 200. And we have 1000 at 200. These are the heavy hitters here. These are the expensive caps. But we will replace these and clean off the glue down in there. And then we'll replace this guy and also clean off the glue over there. And then after that, we'll move on to the input and amp board. Okay, solder sucker is hot. Let's go. These are glued in pretty good, so I'm gonna clean out the holes and then just rip them off the board. Making sure I do a really good job cleaning out the holes. Luckily they made these the right size. Just noticed a bent pin on the dashboard. Fix that real quick while I'm in there. Alright, they look cleared enough. Since the glue is kind of fresh on these. Honestly, these things probably didn't need to be replaced, but let's, for the sake of making a good video, let's see what they read. They're probably still good. Yeah, 440. Let's see what this guy reads. 444. Let's see what a new one reads. 448. So, yeah, these are probably still good. But I don't know who XC is. I don't know, maybe I'll leave them as emergency caps or use them in something else, some other little bootleg project. The glue actually came off pretty nice. I'm happy about that. I wonder if I could get it all to just come off without having to use heat. Just by doing a little pick and pulling. So far, it's coming rough. Alright, not totally, but we got a lot of it off. That counts. That counts for something. Would have been nice if I could have just popped it all off. I don't want to damage this jumper resistor too much. Even though that's all it is just a jumper. But you got to get the glue off. The short right here actually wouldn't matter, but I still want the glue out of here. So I will do whatever I can to get most of that glue out. It was nice to not have to cook the board with heat though, because these Carly capacitors that are over here don't like heat. These yellow capacitors, so if you can get the glue out without having to dump a ton of heat onto the board, that's a win. And it looks like we have done that. Just one little stubborn piece in there that I can't get out, of course. There it is. Got it. Got it. Alright, let's pop the new caps in. Plus. And plus goes over there. So here's an interesting little tidbit too. To convert this to 230 volts, all you do is remove these two resistors right here, and the two pins in the center, you just put a little jumper across them right there. That's all you have to do to make this run on the 230 volt. So if you live in Europe or somewhere where 230 is common, and you want to use one of these amps, that's all you got to do. These holes on these things are incredibly loose. I'm just going to solder one in and I'll try to anyways. Fill the hole so I could tack the cap in place. Kind of crazy. It's not a very common thing to have to do, but they made the holes a little too big on this one. Uh-oh, did I put this one in backwards? Sure did. That's what I get for paying attention, right? Luckily, I only had one side in. The square pads are positive on this board. We will get that soldered in. I should be using a thicker solder for this, but I'm not. Alright, 2 down, 1 to go. Come get rid of this. Put that away. Let's go to this big guy up here. He's probably good too. But they're getting replaced anyways. And the glue came off nicely with them too. Never seen that one before. A JEE, a G. Maybe that's the series. I don't know. These are only 85C. The ones that are going in there are 105C. So they're better caps anyways. I'm just going to throw them out. It's not like they're that expensive where it's going to make a huge deal if I have to buy a cap. Alright, glue's off of this one too. I don't know what I had this guy in, but there's a through hole on him. That's got to come off. Ripped a pad out of something when I was using this one. It's a new cap. Must have damaged something and just said forget it and ripped the cap out because I couldn't fix it. But there was definitely part of a through hole on there. Not anymore. Just for the hell of it, I will test and make sure this is good. I'm sure it is. This meter isn't really accurate when you get above like 680, but that's close. We're going to say that's good. Doesn't even if I grab a brand new one. Yeah, doesn't really matter. That's what happens when you buy a cheap meter. But it's good enough. I'm not spending $500 on a capacitance meter. I just don't use it enough or need it enough. I know these are good caps and they're quality caps, so I'm not worried about it. Unless I hear otherwise and somebody says that they've been having problems with them. So far, that has not been the case, and they have been very reliable for me. The reason I'm using the big tip in the hot iron is I want to make sure that I get a decent amount of heat in there because I want the solder to flow. You know, cold solder joints will ruin your day. You know, you'll send it out, the person will turn on their subwoofer, and then a couple hours later the joints vibrate and break loose. Then they're calling you, hey, you didn't fix my stuff. I've made mistakes before, but my goal is to have 0 callbacks. After I send you your amplifier back, I don't ever want to hear from you ever again. And that's a good thing. Alright, on to the amplifier board. So we're going to pull this guy out. This guy doesn't come out, but this guy does. 6 screws. 2 mounting screws, 4 heatsink screws. Making good time tonight. Surprised I don't have more people watching. I figured this would be a hot topic because I've had a lot of email requests about it. Here we go with the thermal crap everywhere. I'm not going to take these out. I'm just going to loosen them. One, because there's thermal goop all over them, and 2, because they have that acrylic stuff on the screws, and it's going to make them really hard to back out. And I can get the board out by just loosening the screws. Hopefully the heat sinks will cooperate. Nope, they didn't. So now I gotta go ahead and pull all of them out anyways. All of that was for nothing. Nothing but annoying me and making a mess of my work pad. So these are smothered in the thermal compound. So I'm going to try not to make a mess, even though I can say I already am. And I got to take the heat sinks off because the thermal pad's shifted, so they all got to come off. Can't always be lucky, I guess. These things are hard to get out. I usually use my wire strippers to hold them. They have like little teeth in there and they actually grab the plates pretty good so they don't slip. Again, this is more of an optional step, but since I'm servicing it for somebody, I'm doing the full recap. This guy also sent a return shipping label, so anytime you send a return shipping label, I want to go the extra mile. So if you're watching these and you're planning on having me do a repair, keep that in mind. You get the royal treatment if you send a return label, just because it saves me a bunch of headaches. Unfortunately, like PayPal, since I use them, I wish I didn't have to, but since I use PayPal, they do not have an option to create a shipping label from an invoice that I send. So I have to go through and do all that manually. It's just, I don't know, it's a pain. Especially when I already have like address information and everything already saved in an invoice. But it is what it is, no big deal. Life will go on. Okay, we're going to recap this guy. Try to minimize our contact with the glue, even though I already know it's going to go everywhere. Amp board looks to be in really good shape. It's clean. The resistors are clean. I don't think we're going to have any problems with this other than making a mess. So we're going to do that. The capacitors that really need to be replaced are these 4 that are right here. These are the ones that come off the voltage regulators. If you do nothing else, you gotta replace these 4 just because they get hot over time. These things get scorching hot and they just burn those caps. So the forever caps, you can leave the forever caps in there if you want. They're actually pretty good. But any of these Junzels gotta go. I'm just going to start at the top and work my way around. This is 22 microfarad, 50 volts. I know I have those because I just bought them. Bought a whole bunch. Could probably zoom in just a little bit, maybe. I am going to use the iron to solder these in place just because I don't think I'll be able to get in there with the large tip. And I don't want to change tips again. Unless I have to. So I will do my best to work with how I have it set up. Alright, there's one. These 2 are forever. They're non-polarized. They're in the audio path. I'm going to replace them just because I have the board out. It's right here. I'm going to put some Nichicon bipolars in there. These are both 4.7, 35 volts. So they're both going to come out. Oh, we lost our first pad. Should have left them alone. That's what I get. We'll do a through-hole repair on that one. Unfortunate, but when you have bent leads, that's what you got to deal with. Especially if the connections are made on the top. There's really nothing you can do. It's unfortunate. But we can fix it. We have the tools and the power to fix it. Alright. 4.735 forevers. 4 points. Oh, jeez. That wasn't good. It just shot caps all over the place. I hope it went on the floor. If you sit on the leads of one of these caps, you'll know it. If you hear me scream, you're gonna know what happened. All right, one small through-hole repair. Oh boy, ripped out on the top too. First time that's ever happened. I think I might cut the leads off of the rest of these just to make sure that I don't do any further damage. I don't trust them anymore now. I don't want extra work. Sometimes it really is unavoidable though, so if you tear a pad off, just, know that it happens to the best of us. Oh, that was still connected, so I'm going to keep my fingers crossed that it remains connected and the trace is okay, and once we solder it in, it should be fine. But yeah, the reason that it's the freaking bent leads. The whole reason that happened is because these damn leads are bent. It's extremely unfortunate. But we can fix it, and we're going to fix it right now. I should have cut the zip tie too. That's another mistake I made. Because I didn't cut the zip tie, I'm getting thermal paste all over everything. Alright, I wanted to expand that hole just a little bit. And then we're going to solder our cap in and check and make sure we have continuity. And we should. It should be okay. And if we don't, I'm going to fix it. I'm going to solder the bottom and the top of this to make sure that we get a really good, strong connection. The top actually soldered itself, but I'm still going to go in and touch it up again and just make sure we get a little bit more on there. I don't want a chance that, that connection can break. So now just to verify that it's still connected, I need to find where that trace goes. It looks like it goes to this resistor over here, so I'm getting noise. That's a good sign. So I am going to say it is connected. We'll find out right away when we put an audio signal in there if we don't get any sound, because these are directly in the audio path. So if I don't get any sound, I will know that the issue lies with that pad that was ripped off. Power supply. No, I think the leads were bent on that one too, actually. Yeah, bent leads just caused so many headaches. They're probably bent by a machine too. I don't know. But either way, all these, I'm going to cut the rest of these caps off if I can get in there. At least try to. I think this is another, yeah, this is not the last non-polar, 4.735. So we'll just do one at a time now. And we're on damage control. This is the right way to do it in my opinion anyways. It's a little bit slower, but it's a lot better for the board. I don't want to say you're guaranteed to not damage the board, but the likelihood of damaging the board goes way down. Interesting that most of the capacitors do not have good solder joints on them, the little bead capacitors, little ceramic jobs. Alright, that guy's in. You can bend the leads after it's soldered all day long. Go ahead. I have no problems with that. Let's see what these caps are here. This is 47. Yeah, they're different values. Maybe these two are the same. No, of course not. Can't make it easy on you. $100 at 35 volts is next. I'm going to pull these wires out to make life a little bit easier on me. Cable is twisted in a really funky way. Pulling the leads and then clearing the holes really does make it easier sometimes. This one, the darn lead just fell through. Usually they're magnetic mildly, and you can get them out. Yeah, there it is. Not always. Alright, 135 volts polarized. I still don't understand why they didn't make the holes for these capacitors the right size. I cannot for the life of me figure that out. Alright, I'm gonna do a little trimming. Got 3 to go. And then we're on to the feature board, as they call it. I don't know why it's called a feature board. It doesn't really have any features. It's just a preamp. How am I gonna, let's see, can I get in there? No. $47.50. That's 100. This one's at 47. Alright, we'll do the next two because they're the same. My iron seems like it's really cold right now. I don't know what's going on. I'm sure the lead-free solder doesn't help. Alright, these last two and then one more. We'll grab one more of these 100s because we're going to need it. And 247s. We're going to need those. Alright, last one, and then we can move on to the other board. Interesting, they had a little test point on there. Is that the one we want? Yes, it is. I don't know why that leg doesn't want to come out. That one did. There is a pretty big thermal plane underneath it, so it's probably sucking a lot of the heat out. Alright, last cap on this board. Make sure our polarity is good. Our leads are out of the way, and get them in there. It's actually pretty good. Yeah, there's a test point on this trace, which I don't recall seeing, but it's there. Either that or it's just a through hole tapping in off of that. Whatever the reason, there's something there that had solder in it, so I refilled it. Alright, this is done. We can set this aside. Put these thermal paste covered ceramic heat sinks with it. And the only way you can get to this board here is by taking that board off. So I do not replace the cap that's glued, this one here. I just leave that one alone. But I will replace all the other ones. These ones are power supply caps. I really need the smaller tip for this. I'm gonna change it out and put my small tip back on. I might even use my really small one. I think I might actually. I can lay out the diagram of a sub 10. Yeah, I can actually. Except you're not watching right now. Well, here, I'll do it just in case you come back. Because I have the diagram of a sub 10 power supply. Just give me a second to find it. It's the amplifier section. If you Google sub 10 schematics, then you can probably find the exact same thing that I'm looking at. There you go. There it is. I don't know if you'll be able to read that. I'll try and get you a little more light. I don't think that helps. But there it is. Here, I'll even zoom in for you. Why not? I feel like being nice tonight. I don't know if it'll focus, but alright. There you go. It's upside down. Let's try that. Input power goes through filtering, goes to the diode bridge. There's your power section. There's your Pdc board. There is your transformer, and then there's your outputs. And you can see that it's not made by Klipsch. They were made by Indigo, who is no longer in business, so nobody can yell at me for posting that. I still won't send it to you, though. You have to find it yourself online. I feel like that's fair. Alright, I'm getting ready to change the tip here for my solder sucker here. And we will finish the RW-10D recap. So we got 1, 2, 3, 4, we have a few caps on here to replace. 6. So 9. 9 caps to replace. And possibly a voltage regulator. The voltage regulators on these are known to sometimes be flaky. If we don't get any LCD picture, it's almost always the voltage regulator. And they're not hard to replace. If you have to replace it, they're pretty easy to do. These right here are our impedance matching resistors. RCA jacks buried in glue. I have replaced these before. I have some. Try not to break your RCA jacks. Actually, I'm out of stock of those. I only have the quad plugs. So yeah, don't break them. If you break those, you're out of luck, because I don't have any of them. Alright, we're up to temp. Let's get back to work. Trying to be careful with these because I really don't want to damage the feature board. These are 247s at 50 again. It's so easy to work on when the leads aren't bent. These are the caps that smooth out the 5-volt supply. Let's make sure your polarities are correct on these. That's kind of important. Since it's sliding off my head there. Alright, we'll just tack one lead. Get it into place, and then we will solder it in there. I didn't like the way that one soldered in. It looked like it was crooked. That bothers me. next? $22 at 50 polarized. This joint just looks a little bit cold to me, so I'm going to hold the board upright and hit it from the top. There's probably a plane, thermal plane that goes through the board that hits. We don't want to burn our wires. That would be no good. So make sure you get those out of the way. I'm being a little more gentle than usual just because this board, again, I really don't want to damage it. That's another 22 at 50. The feature board is the one board that I cannot really replace if it's damaged or fix it, because it has a microcontroller on it, and I don't have the software for that. And I don't know how it works. Be nice if I could get that, or if I could take a dump off of there and back it up somehow, but that is beyond my abilities at this current time. $47 at 50. I can tell I'm going to have to order some caps soon, because this plate's doing a number on my 47s. I am running low. I know this is the boring part, but we'll get to the good stuff in a little bit. Only a few more to go. I have one down here, which is going to be hard to get to. Probably going to have to blob it up a little bit with some lead, make it happy. Yeah, since it's on an angle, I can't get a good seal on there to suck out the hole. I think my tip is clogged too. which makes it a little worse. Where is my tip cleaner? That's going to be the next thing. I got to find that. I can cheat and use a resistor. I think that cleaned it out. Now we just gotta grab the cap. This one didn't break the pad off, but it did lift it a little bit. I did put a ton of heat on there, so it's kind of my fault, but I couldn't get it out. It will be thoroughly soldered though, so we'll be alright. I'm actually gonna flip this over and make sure I get it soldered good on the top with gravity. And I know this is probably not visible, but I need a good joint on that. Alright. 3 more caps. One of these is in the power. I'm doing these 3 right here. This one and then these 2 little ones. The 2 little ones are for the auto on off feature. And the big one is one of the power lines. I think it's the plus 15. I hate not being able to get to these. Just gotta smother them with solder so you can get them hot enough to pull out. Should be a 22. No, it's 4.7 and the voltage is 50. Check your polarities. I've been doing that most of the time. I know this is going to be hard to see, but I just want to get this done. So just trust that I am doing a good job here. Well, this is one part that is kind of a pain. There's a resistor that they ground to one of the cap terminals. This one's like smothered in glue, so I'm going to try and get it off without doing too much damage there. I think these are both 10 microfarads, so I'm going to snip them. Oh, I'm not going to be able to get the cutters in there, damn it. Well, I can unsolder one. I don't know why this is not clearing the holes. What I need to make is a curved tip for this. That would be sweet. Then I'd be able to get into those really hard to reach places. So I was able to get one leg loose. I can probably just get this one hot and pull the cap out. I'm hoping. Let's see what happens. Yeah, I did it. I was able to do it. I don't know if I can clear the hole. I'm going to try and clear the hole from the top. All that glue makes this really a pain. Nope. No luck. That's going to be a tough one. What was the voltage on these? I believe it was 16. Yeah. Put 2 big caps in there and we'll be back in business. I gotta clean up this glue that I burnt a little bit. Actually, it's coming off. I'm just gonna pull the glue off. I didn't want to pull it off, but now I'm gonna pull it off. This is one of those spots where the glue really doesn't hurt it. It's really just a 0 ohm resistor, so if I ended up damaging it or ripping it off the board, I could just put a jumper wire on there and that would fix it. I'd rather not do that, but alright, let's see if I can clear this hole now. We are in business. The last 2 caps are going in. And again, I apologize that you can't see this, but we'll look at it in a minute. We will review it together. There's just no easy way to work on this because I can't get the board out. At least not with risking doing damage to the board, and I don't want to damage this board. I probably do have one on the shelf, but that still doesn't make it worth damaging. should be using my kickstand. That would make life much easier. We're just going to throw a big old solder blob on there. Make sure the cap is soldered in, and make sure that that resistor is connected. Or jumper, or whatever you want to call it. Okay. Trim the leads. And we will be in business. Reassembly time starts next. Okay. That's what it looks like. The little resistor is connected back to the ground of this cap right here. And we recapped this board fully. We left our little factory rework cap alone. That should be fine. Oh, I missed one. I missed one cap right here. That little guy. We got one more. One more. Okay, feeds the power to the microcontroller. It should be another 10 at 16 volts. Yep. Alright. One more. Trying to hide on me. Again, this is probably not totally necessary for most repairs. If you're doing this for yourself, I don't know if I'd go into this amount of depth, but since this is not my amplifier, and like I said, I don't want to see this thing again, I'm doing a recap on it, because it's approaching the age where it's necessary. Okay. Making sure everything is in right. I'm just checking polarities really quick. Making sure nothing's put in backwards. These are marked with a indicator on the board, so it makes it kind of easy. And everything looks good. So I'm going to snip those leads, and then we're going to get back to reassembly. It's a lot of caps. Look at all these caps over there. It's littered with them. Alright. Now my favorite part, dealing with thermal paste. I'll show you. Hold on, I need a sip of coffee. Time out. Alright. So here's what I do with all this. Actually, this thermal paste is pretty gnarly. It's not even thermal paste anymore. It's just like thermal chunk. Alright. Gotta clean it up. I didn't want to, but this stuff is just no good anymore. And I can't, as much as I hate dealing with thermal paste, I can't send it back like that. if it's flaking off in like crispy chunks. That is no good. You're getting no thermal capacity out of that. So yeah, we're going to take it off and redo it. And you know it's bad because it's not even getting my razor blade dirty. I will thoroughly clean the little ceramic pads after I get the plate cleaned up. Now a little bit of residue on here ain't gonna hurt nothing. Doesn't have to be spotless because we're gonna be putting thermal paste back down, but any like chunks that are not cooperating have to come off. You can't leave chunky thermal paste on there. Alright, now we gotta clean the heat sinks. There's a little bit of good stuff left on there, but not much. It's mostly crusty. When it gets crispy like that, you're not really getting any thermal transfer. It'll melt a little bit as it heats up, but I don't know. That ain't the right way to do it. This needed to be repasted. And again, you know, like this amp is about the age where, you know, maintenance like this needs to be done. No different than a computer, you know, the thermal paste on your computer gets old and dries out and gets gnarly. So if you're into, you know, gaming or high performance computing, you know you got to change it after so many, you know, hours of use. All right, that's good enough. That stuff didn't even make a mess. You know it's no good when that happens. I'm gonna clean off the devices too. I no longer trust them. And this stuff gets hardened in the tip and it just does not want to come out. You can turn the soldering iron off. This one is thermal paste. I don't know what the other one is. Don't need a lot, just enough to hold it down. It will spread when there's pressure on it. With these ceramic ones too, when you're repasting these, you want to work them onto the plate a little bit. You don't want to just set them on there and then start clamping down the MOSFETs, because if there's a glob underneath here, you could crack them. It doesn't really take a whole lot to crack these. And by working them back and forth I'm smushing the excess out. I'm also ensuring that there's a nice even spread underneath them. They line up right by the screws, so let's clean this off. I'm gonna get all that goop off of here. I'm gonna do that over the garbage can, so you won't be able to see what I'm doing, but I just want to get the majority of the dried paste off. If there's any wet stuff on there yet, you know, that can stay and be used for wow, this stuff is dry. Really dry. Can't say I've seen any this dry. This guy must like his volumes loud. Nothing wrong with that. But we're getting there. This is the home stretch. Once we get this repasted and screwed back down, we will be in good shape. Alright, that is clean enough. Doesn't have to be spotless. Just got most of it off. I'm going to just throw a little dot on each one. Make sure they have even coverage. And I'm going to bolt this board back down. And after this is bolted down, I'll readjust and make sure that the thermal pads are in the right spot. And then from there we can start tightening the heat sinks, or the clamps for the heat sinks. This plate is all over the place tonight. Remember not to over tighten these screws too when you take these screws out. If you strip one of these screws, you're done. So I'm just checking make sure that I got even coverage on all these, and I don't. They're out by a little bit. So we can just adjust it. The big one's got to scooch down just a tad, just so both devices are under it. This guy needs to come over a little bit, just so when he smushes down, it's got full support. I will finally grab my kickstand, and we can start reassembly. I'm not gonna lie, these things are a pain to put on. There's no way around it. I like the bar clamps that are used on the Synergy series way, way, way better than these. These things are garbage as far as I'm concerned. But that's what you have to work with. And they work, so. The main reason I don't like them is they're very easy to bend. If you over tighten them too much, they lose their clamping force. So you have to go by visual. You can't go by feel. Because if you go by feel, you'll think you're tightening it, and it never gets tight. And then when you look at your clamp is completely smushed. So you got to kind of just eyeball these, which is a terrible way to do it. So once the clamp hits the plate, make sure it's straight. And then just clamp it until it has like a little bit of curvature to it, you know. And that'll be enough to ensure you get decent thermal contact. These amps don't run terribly hot. I'm going to take a guess that whoever owns this one is either a movie lover or they listen to some music that's got some pretty deep, long bass. But hey, it's good. It's good that something of this vintage still works that good, that it is heavily used. It's the whole reason I do this, is to keep this stuff alive and keep it out of the garbage. And I'm not like a, you know, super echo green type of person, but I also don't like throwing stuff away that's still good. There's no reason for it. Alright, clamps are back in. Now on these, I usually put a drop of something on there to hold them in place. I'll usually put a drop of super glue or E5000, or I'm sorry, E6000, E5000. And the reason I do that is because they're just simple spring-loaded clamps. And they really do better with a little bit of something to keep the screws from backing out. So you could put a drop of super glue on there, you could put a drop of epoxy, anything. Alright, now we need to, I don't know how that got on there. One of the cap leads looks like. Maybe not, I don't know what that is. There's like a piece of wire stuck in there. Weird. Feature board goes to port, the inside port. Doesn't go here, goes here. Don't make that mistake. Feature board, power supply. We bent the voltage regulators out of the way. That's going to keep our cap safe. Now we're going to put our power supply back on. Screw him back in. Then we'll do the, actually no, I'm not going to screw the power supply in yet. I want to put my wires in. And the reason I want to do that is because these are hard to get to. That's not the right way, is it? How did this go? Yeah, it had to have gone that way. That's the only way it can go. Alright, well, I'm going to screw the power supply in because when I yanked on those, the length of the wires moved on me. So I'll get a couple screws in here to hold this guy in place. And then I will readjust the power wires going to the amp board. I still would like to know what that piece of wire is. I don't think that came from any of my cap leads. Maybe it did. Alright. Now you gotta, it's hard to read, that's why I did that. CD plus is on the top. CD minus is on the bottom. So there's plus. And there's minus. Then they come over here, and there is plus. And see if I can put them under that. That's a little bit nicer. Plus. And minus. Alright. Speakers are way down in here. They're hard to reach. I'm not going to connect up power because I'm going to use my power line. We have these 3 screws. And I got to make sure I replace the fuse. We got the blown fuse still. Plastic screws, you know, don't need to be very tight, just minimally snug. These things strip out super easy. Alright. We are kind of in business. And I say kind of because we still have to do a test. So I'm going to hook up the speakers before I give it any power. Just because that's a tight area to reach into and I don't want to be messing around in there. Now, the one thing I'm going to do, because since this is a digital, is I am not going to give it any audio input. And I'm doing that just to verify that the volume isn't set to, you know, 800 and it's going to blow my eardrums to pieces. My little scope is dead. Again, I'm doing all these connections before I power it on just because I don't want to be reaching in here when this thing's fired up and running. Alright. Let's see if I can move this. Move my power supply, give me a little bit more cable length. And I can. Alright, we can see the scope. We need an audio source. This poor cable's been run over by my chair so many times. I'm surprised it even functions. Okay, that and one trusty LCD. And this is why I tell everyone to not send their LCDs, because generally they don't go bad, and I usually have one. Now this connector up here, be careful when you're plugging it in. It only goes one way. If you jam it in there the wrong way, you're going to break it, and I can't replace that. Do not break this connector. Actually, we got to pull the audio out. I'm breaking my own rules here. Okay, we have our display board with our buttons, which is probably upside down. Audio source is not connected. Power is. Got nothing on our meter. Alright, let's see what happens. Current limited. Here we go. That's a good sign. Klipsch RW-12D. It's going to be really hard to see that, but the volume is. Oh, you can see it for a second there. Man, that backlight really drowns it out. Well, the volume was at negative 17 dB, which is too loud. I prefer 32 for testing. I'm going to go through and erase all his settings. I like flat. Low pass I set to LFE for movie mode. Phase I set to 0. Save the setting in music. The only reason I do this is because I need to. I don't know if that helped. Yeah, hey, you can read it if I turn the brightness down. So yeah, this is how I test. I keep the volume at 32. EQ mode flat, and I don't use any of the crossover. Turn the crossover off. Phase at 0. That way, what I'm looking at on the scope is more of the natural signal coming out of the audio source. And you can see we got something on there. Voltage is a little bit high on the there we go. 20 milliseconds is a little better than 200 when we're measuring frequency, but we got 40 hertz and I'm giving it 40 hertz, so we have audio. I'm going to slowly bump the volume up. You could see it go up on the scope. Beautiful sine wave. I mean, it looks wonderful. So I'm going to let this thing test for a little while. It looks good. It sounds good. So I'm going to let it burn in for a little bit, and then I'm going to call this guy done. Alright, what are we? 2 hours, not too bad. I wasn't really rushing through this one, so I think that was worth the time. You can see I have a hole in my wall where I'm doing my work down there. So I've been busy. I hope to do some more amp videos this weekend. I got some stuff I got to get through. I do have some work on the house I have to get done as well, so we will see. We'll see what happens. But RW-12D brought back to life. Fresh recap. This amp is basically showroom brand new. I appreciate you guys tuning in. If you have any questions, hit the comments. Remember to like and subscribe, and I will see you for the next video. Thank you for tuning in.